Hey, welcome to this video. In here we're going to do a quick note cards review for chapter 8. Let's start with integration by parts. The formula are written this way. The integral of u dv is equal to u times v minus integral of v du. I prefer to write u and dv out and then take the derivative of u, which gives us du, take the integral of dv gives us v, and then cross multiply u times v minus v times du. But we can also approach it in a simpler way, which is tabular method. However, to do this, we have to meet some prerequisites. Well, what are those? To use tabular method, we have to use when the derivative of one function eventually goes to 0 and the other function is continually integrable. An example for that will be u for u to be x squared and dv be e to the negative x. Notice when we differentiate x squared over and over again, it will eventually be 0. However, for dv, which is e to the negative x, if we continue integrate that, we will never go to 0. It will always be integrable. If this is the case, then we can use tabular method. To use that, we should ignore the dv, the first term for dv, and then times u and dv for each corresponding terms. Don't forget to put the signs next to the u terms. Always starts with positive sign. Therefore, ultimately, we can write our answer in this way, which is each u times their corresponding dv. And don't forget to plus c at the end. Some guideline for choosing u in integration by parts. We will follow Lie-Eat theorem. What is that? Well, this rule is L stands for logarithmic part, I stands for inverse trig part, A stands for algebraic parts, which is also polynomial, T stands for trigonometric part, and E stands for exponential part. And what is it really saying is if function is above the other function, then that is the u. An example will be the integral of x to the nth power times e to the ax dx. We will choose u as our x to the nth power because algebraic is above exponential. And another example will be the integral of x to the n times arcsine of ax dx. We will choose u to be arcsine ax because inverse trig is above algebraic. What is the integral of natural log of x dx? This is x natural log of x minus x plus c. This is good to memorize. What is the limit as x approaching infinity of 1 plus 1 over x all to the x power? This will be e. And this is a very good format for you to remember because sometimes the question will twist it a little bit. For example, if you put a constant other than 1 on top of x, then you will the answer will also be changed. But the original function is always yield to e at the end. And what is the limit as x approaching infinity of the quantity squared of x plus 1 over x all raised to the x power? Notice this is pretty similar with the previous one. However, the answer, as you thought, is still e. So just they are pretty similar, but ultimately they are the same. So if you kind of divide divide the numerator and the denominator into two parts, the first part will be x over x, which will be 1, plus 1 over x, which will just be 1 over x. And this is the case that I said before. What if we replace the constant on top of x with another constant other than 1? The answer will be e to the negative 5. Why is it negative? Because there's a negative in front. Remember the original function is 1 plus 1 over x. So if you change it to negative, then e has to be raised to another negative power. What is the limit as x approaching infinity of this thing? Well, you maybe guess this will be 1 over e. Let's take a look at some determinants. So if you plus 2 positive infinities, you will get a positive infinity, no doubt. If you plus 2 negative infinities, the answer will be negative infinity. If you raise 0 to the infinity power, it will still be 0. Same thing as negative infinity. This one will be positive infinity, however. What are some indeterminates, by the way? 0 over 0, this is assigned to use L'Hopital. Infinity over infinity, also L'Hopital. 0 times infinity, you have to reshape it before using L'Hopital. 0 to the 0th power, indeterminate. Infinity raised to the 0 power, Infinity minus infinity, this is kind of tricky because some mathematicians will argue if one infinity has more magnitude, but in most of the cases, we don't have that clue to help us figure out, well, which one is bigger. So whenever we have doubts, just say it as indeterminate. Same thing as 1 raised to the infinity. Partial fractions. This is also very important. I recommend you to take a look at your notes or any study materials that your teacher or professor provided to you. But basically the key idea for partial fractions is you are using it when it gives you an integral. You will write it in partial fractions to help you take the integration of it. And most of the cases you will end up with a natural log of absolute value inside something and plus c at the end. Improper integrals, here are the things for that. So the integral of a to the infinity of f of x dx is equal to limit as b goes to infinity of integral from a to b of f of x dx. So notice we are simply replacing infinity with b. And instead of writing a to the infinity for an integral, we are using limit as b goes to infinity of a to b as our integral. Another example will be from negative infinity to infinity as our integral for f of x dx will be negative infinity to c plus c to the infinity. So notice the difference with the above formula. Rather, we are not replacing it with one variable. I mean, in this case we are, but we just, instead of using a variable to represent an infinity, we are using a variable in between of the two endpoints of the interval. Even in this case, infinity are not necessarily at endpoints, but for simplicity, we are still using a variable to represent it. And we are getting limit as a goes to negative infinity of this a to the c of f of x dx plus limit as b goes to infinity of c goes to b of f of x dx. So one key idea for this type of questions is do not leave the integral as infinity. Like, don't include infinity for the bounds of our integrals. Always replace it using a variable. More improper integrals. Take a look at this. The integral from 0 to infinity, if the vertical asymptote is at x equal to 0 and upper limit of infinity, then we can write it in this way. Limit as a goes to 0 from the right side of a goes to c, the integral of f of x dx. We are choosing a number between 0 and infinity. So c in here, it just can be any number between 0 and infinity, because we are trying to prevent from counting the vertical asymptote at x equal to 0, because otherwise it will just be indeterminate. So same thing as here, b goes to infinity of c goes to infinity f of x dx. An example will be from 1 to 3, the integral from 1 to 3 of 1 over x minus 1 dx. Notice we have a vertical asymptote at x equal to 1. Therefore, in order to integrate that, we have to reshape. Limit as a goes to 1 from the right side, a to the 3, like integral from a to 3, 1 over x minus 1 dx. Because in this case, we successfully prevent a goes to 0. If a is exactly 0, then if a is exactly 1, then everything will be meaningless. So f of x is not defined at c, and c is between 0 and 1. So the integral from 0 to 1 f of x dx is equal to limit as a goes to c from the left side, integral from 0 to a f of x dx plus limit as a goes to c from the right side, and from c, and I should replace this with another variable. So I can change it into b, so this should be b to 1. Yeah, sorry about that. And yeah, that's all for this video. I hope it helps. Thank you so much for watching. Hope you have a great day.